All right, welcome, physics friends. I've got a few of our friends here today, and we're going to talk about velocity versus time graphs. And I've got a couple of them here that we'll just talk our way through. So why don't we get started? Like, what questions do you guys have about velocity versus time graphs? Like, why did you come in here today? What questions do you have about these things?
Well, I got these wrong quite a bit. I tried to do the 3 different ones, but it was just how to find what I was looking for, and because some of the questions I tried 3 different answers and it didn't work any of the times.
Mm-hmm.
I'm trying to get to the specific questions that I have. But...
Sure. What about the rest of you that are here?
I mean, I took notes, but I just didn't really understand.
Okay. Here's the different tack that I want to maybe try, and this worked on with Lex, was that in this graph right here, what I want to talk about, this is a very special place right here. Do you know what it means when your velocity is 0 meters per second?
No movement?
Yeah. In really simple words, it just means that you're standing still, right? And as time goes by, so here's time equals 1 second, time equals 2 seconds. And as time, and I have a vertical line here, as time is ticking by, 3 seconds, 4 seconds, 5 seconds, 6 seconds. As time ticks by, if the graph is getting farther away from this, we call this speeding up. As time ticks by and the graph is getting closer to 0, we call that slowing down. Right? So when you look at these graphs, let's start with letter A. Is A speeding up or slowing down?
Speeding up.
Why?
Because it starts at a velocity of 0, but it gets further away from your x-axis.
Exactly. If you start at a velocity equal to 0, that means that you're stopped, and that the only thing you can do is speed up, right? Letter B. What's B doing?
Slowing down.
What?
Slowing down.
Slowing down. And it's funny. It can be this lulls people into a false sense of security, because look at A. A is going up, isn't it? Oh, so A is speeding up. So if the graph goes up, that means it speeds up. And if the graph goes down, that means it slows down. And people think that, but that couldn't be farther from the truth. Because look at letter E. What is E doing?
Technically speeding up.
Yeah, right? So people would think, oh, this graph is going down, so it's slowing down. But no, it starts out with the velocity equal to 0, and then its velocity is getting more and more negative. So this is speeding up. It's getting farther away from 0.
What confused me on the questions and stuff was the y-axis, I guess you'd call it.
Yep.
I was confused because it was going negatively, so I just don't understand.
Oh, yeah. So I guess I wrote that in there so to just show that down equals negative, like it is here. -2, -4, -6. So in this y-axis, down is also negative here too.
Okay.
Letter D. What's D doing?
Slowing down.
Yeah. Right? It's funny because anything below this axis is opposite. So as this graph goes like this, that's slowing down. It's even though the graph is going up, it means it's slowing down. And in this graph here, it's going down, that means it's speeding up. So it's kind of opposite in a way down here. So don't think to yourself that, oh, the graph is going down, that means it's slowing down. Not always. So that's thing number one that I think kind of was helping some of the people that I talked to yesterday was if the graph is converging towards that means it's slowing down. And if it's diverging, if it's getting away from 0, that means it's speeding up. The second thing that people who are having a hard time doing is if I asked you which one of these is it moving in a positive direction, right? So which one of them are moving in a positive direction? And the way to think about this is here's that special line again. Anytime the graph is up here, you're moving in a positive direction. And anytime the graph is below the axis, you're moving in a negative direction. So like, go to A. Is A moving in a positive direction or is A moving in a negative direction?
Positive.
Yeah, and if you look at this, every single point that I pick on this graph, these are all positive velocities, right? A velocity of 1, a velocity of 2, a velocity of 3, a velocity of 4, a velocity of 5, right? These are all positive velocities. So over this entire interval, you're moving in the positive direction, and you're just getting faster. Letter B. Is letter B moving in a positive direction, or is letter B moving in a negative direction?
Negative, because your velocity is going from 6 to 0.
Got it. What's my velocity at the very beginning?
6.
6. Positive or negative?
Positive.
Positive. What's my velocity right here?
4.
Positive 4. What's my velocity right here?
2.
Positive 2. And then you end up at 0. At any time, was my velocity negative?
No.
No. So I'm always moving in the positive direction, whatever the positive direction is. So I'm never moving in a negative direction.
See, I feel like that's like just a little bit hard to like understand.
Sure. No, my velocity is trending towards a negative, but the way that I'm moving, I always have a positive velocity. So I'm always moving forward. Yeah, I agree with you that this is a really tricky thing. That it's like, the graph is negative. What does that mean? That means that the acceleration is negative.
Mm-hmm.
But the position, I'm always moving in a positive direction. Letter D, for instance. Letter D, is that moving in a positive direction or is that moving in a negative direction?
Negative, because it's on the negative side.
Yeah, and if you look at any single point, my velocity here is negative 4. My velocity here is negative 2. My velocity here, negative 3. At every single point, I'm always moving in the negative direction. I start out really, really fast, and I end up stopped. But I'm always moving in a negative direction. Letter E. Is letter E moving in a positive direction or a negative direction?
Negative.
Yes, because it's below that axis. Sometimes where it gets a little confusing, and the really difficult graphs to understand are what happens when a graph like crosses over the axis. You know what I mean? Like, what if I have a graph that goes from one side to the other? Then you get multiple things happening. Because at the beginning, you're moving really, really fast in the positive direction. I'm slowing down. And then I stop. So for this first half, I was moving forward. And then I stop. And then I start moving in the opposite direction. Now I'm moving at negative 2, negative 4, negative 6. I start moving in the negative direction. This is a really good example of a ball rolling up a hill. Like if you've got a ball and you roll that ball up a hill, it starts going up the hill really, really fast, and then it slows down, it stops for an instant, and then starts moving down, getting faster. So when you have
Sorry.
No, go ahead.
So on the first half, you're like decelerating?
Yes.
Then you stop, but you're decelerating in a positive direction, technically?
Yeah, so...
And then you stop, and then you're accelerating in a negative direction?
Yes. Yes.
Okay.
Yes. You could say this. Over this entire thing, I am accelerating in the negative direction. You are right to say in the first half that I am decelerating because I'm slowing down. And then in the second half, I'm accelerating. And that's exactly what a ball does when you roll it up a hill. It like slows down, it decelerates, it stops, and then it accelerates as it rolls back down the hill. Or even just throwing it up in the air. It does exactly that. So when you said it's decelerating in the you're kind of using like double negatives there. I would say it's accelerating in the negative direction, and then it's also accelerating in the negative direction in both halves.
Okay, because the positive direction and negative direction thing just throws me off.
Yeah, and it depends what you're talking about. Like, are you talking about like your position or your velocity or your because your position can be positive or negative. Your velocity can be positive or negative, and your acceleration can be positive or negative, and none of them are tied. Like, just because this one's positive doesn't mean that one's also positive. Like, they are totally separated from each other.
Okay.
So let's try this. Like, I'm gonna give you a little quiz. And we'll just maybe go around the horn. So what do you think? Like, A or B? Is A getting faster or getting slower?
A is getting faster.
Yep.
So it's accelerating.
If I put letter C right here, is C moving in a positive direction or is C moving in a negative direction?
Well, it's technically not moving at all, right?
No.
Okay.
It is moving.
Oh, really?
Yeah, it's moving at 2 meters per second.
Oh, okay, so it's like a constant speed. But
Yeah.
if it's on zero, then it's not moving.
Yeah, exactly. Where this really gets wild and gets people is that if this was a position versus time graph, letter C represents not moving, right?
Mm-hmm.
Last chapter when we were dealing with position versus time graphs, a horizontal line means you're just not moving, right? But now, since this is a velocity versus time graph, you're right that something is not moving. Something is staying the same. And what is staying the same? It's the velocity that's staying the same, not the position.
So it's constant. So your position is still changing even though it doesn't appear to be that way.
Yeah, your position is still changing at a constant rate of 2 meters per second. Now, my position could be negative. You know what I mean? I could be at like negative 10, but then 1 second later I'm at negative 8, and then 1 second later I'm at negative 6. I'm still getting more. My velocity is positive, but my position can be anywhere. Like this does not tell me where I'm standing. I could be standing in the positive numbers. I could be starting at 10, going from 10 to 12 to 14 to 16, and so on. Let's look at letter. Let's go with E. Is E getting faster or getting slower?
Speeding up
Yeah. Why?
because it starts at a velocity of 0,
Yes.
and even though it's moving in the negative direction,
Yes.
their acceleration.
That's right. That's exactly right. Which of these graphs are changing speeds?
B.
Yes. Are there any other graphs that are changing speeds?
E.
E is changing speed. Is A changing speed?
Yes.
Is C changing speed? No.
No.
No. Is D changing speed?
Yes.
Yes. Yes. So the ones that are changing speed, they're all changing speeds except for letter C.
Because that one's just constant.
Yes, because that one's constant. Which of these graph or graphs are changing direction?
B.
Yes. Are there any other ones? No. None of them cross that line. Like the important line is the 0. So none of them besides B are going from having positive velocity to negative velocity. They all stay on their side. Like if A went like this, then A would also be changing direction. All right, friends. I hope this was helpful. Like what I'm going to do is this. I'm going to go back and I'm going to open up those 2 check for understandings one more time. Like I'm going to give you each one more shot at each of them. And I want you to try it again to see how you do. Just this 15-minute conversation that we had, go back and see if you learned something. See if you can increase your score, right? That's the goal.
I feel like I understand the point of like the directional thing now.
Yeah, it's
Even though you can have a velocity that's like decelerating, you can still be in the positive.
Yep, like letter B is right now, right? You're decelerating, but you can still be moving, quote unquote, in the positive direction, whatever that is.
Yeah.
All right, guys. Hey, thanks for getting up. I know that this was kind of short notice on your end, but thanks for getting up and joining us today. And we'll talk to you later.